sklearnmetricsd2tweediescore. Description: the d2tweediescore metric calculates the squared distance between the predicted and actual values for models that predict a target variable following a Tweedy distribution. This metric is particularly suitable for models predicting positive continuous values with potential overdispersion variance exceeding the mean, such as in insurance claims or count data. Inputs: y true, the actual target values. An array-like structure of positive continuous numbers. Y pred, the predicted target values. An array-like structure of positive continuous numbers, having the same shape as y true. Outputs: d2tweediescore, a single floating point number representing the squared distance between predicted and actual values. A smaller score indicates better model performance, with 0 representing perfect prediction. Steps: the metric calculates the squared difference between each predicted value and its corresponding actual value. These squared differences are then averaged, taking into account the Tweedy distribution parameters power and dispersion. Metrics: mean squared error MSE, root mean squared error RMSE, R squared R. Visualization plots: scatter plot of predicted vs. actual values with a line representing perfect prediction. Residual plots to identify patterns in prediction errors. Distribution plots of predicted and actual values to compare their shapes. Fine-tune parameters. Power: the power parameter of the Tweedy distribution controls the shape of the distribution, commonly set to 1 for Poisson or 2 for gamma. Dispersion: the dispersion parameter of the Tweedy distribution accounts for overdispersion, often estimated from the data or set as a fixed value. Uncertainty methods. Confidence intervals for the predicted values. Bootstrap resampling to estimate the uncertainty in the metric itself. Challenges and fixes. Challenge 1: data with extreme outliers might disproportionately influence the metric. Sample use case that resulted in challenge 1: predicting insurance claim amounts where a few large claims heavily skew the data. Fixes to challenge 1. Transform the target variable, e.g. log transformation, to mitigate the effect of outliers. Utilize robust regression methods less sensitive to outliers. Challenge 2: incorrect selection of Tweedy distribution parameters can lead to inaccurate metric calculation. Sample use case that resulted in challenge 2: using a Poisson Tweedy distribution power 1 for data that is better modeled by a gamma distribution power 2. Fixes to challenge 2. Analyze the data distribution carefully to select the appropriate Tweedy power parameter. Explore various power parameter values and evaluate model performance using the metric.